Okay, so when we're talking about complex numbers, one of the forms that we use is the Cartesian form. So Cartesian form is represented by a plus bi, where a and b are real numbers, but part A gives you your real part, and part B gives you your imaginary part. So keep in mind that I, the imaginary number, is equal to the square root of -1. So this usually comes into play with specific types of quadratic equations where we can't find the real roots. So the complex plane, so when we're graphing these complex numbers, our y-axis becomes our imaginary numbers and our x-axis becomes our real part. So these are still our real numbers. So when you're graphing, say you have 4 minus 3i, then you would go 4 on the real axis and down 3 on the imaginary axis. So that would be your segment composed by the Cartesian form a plus bi. The conjugate, on the other hand, is where you just flip the sign in the middle. So the conjugate, in this case, if your original Cartesian form is a plus bi, then your conjugate becomes a minus bi. And you'll see where that comes in handy in a little while. The modulus is the absolute value. It's the length of the segment. So the way that we do this is we make a triangle. So let's say we have one that looks like this. And let's put it up here. Let's say this is -2 plus 3i. Just making this up as I go. This is composed by the point, the height, if you were to create a triangle out of this, would be 3. And the distance here would be 2. Even I know it's -2, but the absolute value would be 2. So the modulus is the length of that segment. So if you think about making a triangle, this would be 2 squared plus 3 squared equals your modulus squared. And then so your modulus is equal to the square root of 2 squared plus 3 squared. So if you recognize that, that's just your distance formula, but in case you'd never thought about where your distance formula comes from, that's where it comes from. So this is the square root of 13. Okay. Next is the argument. Now the argument is the angle formed between the positive x-axis and our angle. So that would be this side right here, this angle, this big angle. So the thing to remember is that when you're looking for that angle, remember that your coordinates that you have, your x and your y, are cosine theta, comma sine theta still. So you can use that x coordinate. So in that case, we had an x coordinate of 2. That should be equal to cosine theta. So then we can do the cosine inverse of 2 is equal to theta. And we knew it was in the second quadrant. And I know you guys just did all of this 2 HL sections ago. So we started this unit with the ability to use your reference angle. So you should still be able to do that. Okay, moving on from there, if you are adding and subtracting, so if you have A plus BI plus C plus DI, then you're just going to combine your like terms. So that would be A plus C plus B plus DI. So just like normal, just pretend your I is an X. It's just a variable, and you combine like terms. When you're multiplying, you can treat it like an X as well. Just remember that when you get I squared, it's the same thing as -1 squared, which is just -1. So make sure that you go through that extra step at the end. Dividing on the other side is a little bit different. And this is just the division formula. Unfortunately, you don't get that formula on your formula sheet. So you either need to memorize it or know how to derive it. So I will now go through how to derive it. in case you struggle with memorizing unless you understand why something is. So I will go ahead and go through that. So to begin, the most ugly part of this equation is the denominator. We don't know how to divide things when they have an imaginary number. We don't really know how to work with them. So the best thing we can do is convert those to a real number. So you'll remember that since I squared is -1, we want to multiply this so that we get rid of the I. Now, some of you might be thinking, what if I just multiply the whole thing by I? But if you did, then you would end up with the C becoming an I term. So instead, the best way to do this is to multiply by our conjugate. So I'll show you what that looks like now. So your conjugate is going to be we're going to take the conjugate of the denominator so that we can create a perfect square in the denominator. But if we're multiplying by the conjugate on the bottom, we also have to multiply by the conjugate on the top. So conjugate is C minus DI. So it should look something like this. Okay, so now from there, we're going to multiply it out. So we have AC minus BD minus ADI plus BCI. All divided by, and then this time our middle terms will cancel when we multiply it out, and this becomes C plus D. And the reason why is when you multiply out that negative D term, when you multiply that negative D term and then multiply it times the I squared, which is -1, it becomes positive D squared. So from here, sorry, this is supposed to be plus BD. So from here, now I'm going to, since our denominator is a real number, I'm going to group our like terms and split it into a fraction. So we have AC plus BD, our real part, divided by C squared plus D squared. And then I'm going to group the other one in an I term. And so this would be plus BC minus AD divided by C squared plus D squared I. And so that is it. And so this gives you your real and your imaginary part. So basically this is the same thing as the formula that we came up with up there, but if you can memorize the formula for division, it'll obviously go a little bit faster than all of these extra steps because it gets you here to this step pretty quickly. But either way, you should be able to do it. So from here, now we have our homework. You have some Delta Math, which is just some practice with these different elements, but we also have some IB questions. So just like last time, I'm going to do a random drawing because this time some people might not have a homework question. So for question 1, we're going to have Sonia. For question 2, we have Liz. And for question 3, we have Bella. So again, that was question 1 was Sonia, question 2 was Liz, and question 3 was Bella. Now we have 4 more to give out. So question 1 is Tomas. Question 2 is Rohan. Question 3 is Leonard. And question 4 is Knock. So if you did not have your name called, then you just got lucky this time. But hopefully this was pretty straightforward and pretty clear. Hopefully the Delta Math will add some extra practice. Again, if your name wasn't called, and even if your name was called, I recommend looking at all of the problems. However, you are only expected to have prepared for class the one that you are called for. Okay, great. See you guys on Thursday.